Hello everyone. In today's topic, we are going to talk about area of a region between two curves or lines. So this is an application of definite integral. So area of a region between two curves. With a few modifications, you can extend the application of definite integrals from the area of a region under a curve to the area of a region between two curves. Consider two functions f and g that are continuous on the interval ab. Also, the graphs of both f and g lie above the x-axis, and the graph of g lies below the graph of f, as shown in the figure 7.1. So, studying the area of region between f and g, we can conclude that the area of region under f minus area of region under g is equal to the area of region between f and g. So using the definite integral, we have the integral of f of x minus g of x dx from a to b is equal to the integral of f of x dx from a to b minus the integral of g of x dx from a to b. So let us find the area of the region bounded by the graphs of f of x equals x squared plus 2, g of x equals negative x, where x is equal to 0 and x is equal to 1. For the solution, let g of x equals negative x and f of x equals x squared plus 2. Then g of x is less than equal to f of x for all x in 0, 1, as shown in the figure. So the area of the representative rectangle is delta A equals f of x minus g of x delta x, or we can also read that one as change in x or delta x. So substituting the values, we have x squared plus 2 minus negative x delta x. And the area of the region is equal to the integral of f of x minus g of x dx from a to b. And then we have the integral of x squared plus x plus 2, wherein it comes from here. So x squared minus negative is x plus 2. So to find the area, it is equal to the integral of x squared plus x plus 2 dx from 0 to 1. So first, we are going to integrate x squared plus x plus 2, which is equal to x to the third over 3 plus x squared over 2 plus 2x from 0 to 1. And then substituting 1, because we all know that if we are going to substitute 0, it is equal to 0. So therefore, we have 1 over 3 or 1/3 plus 1/2 plus 2. It is equal to 17 over 6. And don't forget the units. So we have square units because we are talking of area. So let us have another one. Find the area of the region bounded by the graphs of f of x equals 2 minus x squared and g of x equals x. For the solution in figure 7.6, notice that the graphs of f and g have 2 points of intersection. So to find the x coordinates of these points, set f of x and g of x equal to each other and solve for x. So we have 2 minus x squared equals x. And then transpose x to the other side, we have negative x squared minus x plus 2 equals 0. So we are going to write it in general form. Then we factor it out. It will become negative times x plus 2 times x minus 1 equals 0. And then to solve for x, x is equal to -2 or 1. So a is equal to -2 and b equals 1. Because g of x is less than equal to f of x for all x in the interval -2, 1, the representative rectangle has an area of delta A equals f of x minus g of x delta x. Then we are going to substitute our f of x and g of x. So 2 minus x squared minus x delta x. And the area of the region is the integral of 2 minus x squared minus x from -2 to 1 dx. And then we are going to integrate 2 minus x squared minus x. So it is equal to -x to the third over 3 minus x squared over 2 plus 2x from -2 to 1. And the final answer would be 9 over 2 square units. If we are going to evaluate -x to the third over 3 minus x squared over 2 plus 2x from -2 to 1. So let us have another one. So let us determine the area under the curve from x equals 1 to x equals 2. So we have the function y equals x squared. In order to find the area under the curve, we are going to have the integral of x squared dx from 1 to 2. So from here, we are going to integrate x squared, which is equal to 1/3 x to the third, and then we are going to evaluate it from 1 to 2. Substituting our upper limit and lower limit, so we have 1/3 times 2 to the third minus 1/3 times 1. Simplifying further, we have 8 over 3 minus 1 over 3. So the area from x equals 0 to x equals 2 is equal to 7 over 3 square units. So let us have other examples. So let us find the area bounded by the curve y equals x squared, the x-axis, x is equal to 1 and x equals 2. So from here, this is the area bounded by the curve and the lines. So let y equals x squared be the integrand, and this will be the lower limit, and this will be the upper limit. So to determine the area bounded by the curve, it is equal to the integral of x squared dx from 1 to 2. So for the solution, we are going to have the integral of x squared dx from 1 to 2. So from here, we are going to integrate x squared, which is equal to x squared plus 1, or x to the 2 plus 1 over 2 plus 1, then to be evaluated from 1 to 2. Simplifying further, we have x to the third over 3 from 1 to 2. Then we are going to substitute our upper limit and lower limit. So we have 2 to the third over 3 minus 1 to the third over 3. 2 to the third is equal to 8, so we have 8 over 3. Then 1 to the third is equal to 1, so we have 1 over 3. 8 minus 1 is equal to 7, so we have 7 over 3. So the area is equal to the integral of x squared dx from 1 to 2, which is equal to 7 over 3 square units. So let us have another one. Find the area bounded by the curve y equals 4 minus x squared and the x-axis. So in here, first we are going to graph y equals 4 minus x squared. So this is the graph of your y equals 4 minus x squared. And then this is the area bounded by the curve and the x-axis. So from here, let y equals 4 minus x squared be our integrand. And then we need to get the x-intercepts, and to determine the x-intercepts, we are going to equate 4 minus x squared to 0. And then we are going to factor it out. So we have 2 minus x times 2 plus x, and then equate it to 0. So we have 2 minus x equals 0, and 2 plus x equals 0. Solving for x, for the first one, x is equal to 2, and for the second one, x equals negative 2. So to find the area bounded by the curve and the x-axis, we have the integral of 4 minus x squared dx from negative 2 to 2. Solving further, we are going to get the integral of 4 minus x squared dx from negative 2 to 2. So the first step, we are going to integrate 4 minus x squared, which is equal to 4x minus x to the third over 3 from negative 2 to 2. From here, we are going to substitute our upper limit first before our lower limit. So we have 4 times 2 minus 2 to the third over 3 minus 4 times negative 2 minus negative 2 to the third over 3. From here, we have 8 minus 8 over 3 plus 8 minus 8 over 3. Simplifying further, we have 16 minus 16 over 3. And from here, we have 48 over 3 minus 16 over 3. So just multiply 16 by 3 over 3. So from here, we have 48 minus 16, it is equal to 32. So we have 32 over 3 square units as the area bounded by the curve and the x-axis. Now let us have the last example. Let us find the area enclosed by the line y equals 2x minus 3, the y-axis, y equals negative 3, and y equals 3. So in here, we are going to graph first. And then this is the area enclosed by the line y equals 2x minus 3, the y-axis, y equals negative 3, and y equals 3. So this is the graph of 2x minus 3, y is equal to 2x minus 3, I should say. And this is y equals 3, this is y equals negative 3. So from here, this is the area that we are going to determine. So in here, we are going to count because as we can see, we are having a triangle. So why not use the formula 1/2 base times height to make our life easier and faster. So 1, 2, 3. So the base is 3 and the height is 1, 2, 3, 4, 5, 6. So from here, we will just going to use the area of a triangle. So we have 3 units for the base and 6 units for the height. So the area of the triangle is equal to 1/2 base times height. So substituting your base, which is 3, and your height, which is 6. So 3 times 6 is 18 times 1/2 or divided by 2, it is equal to 9. So the area of the triangle is equal to 9 square units. Sometimes there are things that we cannot apply if we can apply the basics 1, why not? So from here, we can see that it's a triangle, so it is possible that we can use the area of a triangle. So aside from using the definite integral, if you can use the basics, why not? So that's it for now. Please do your worksheet number 2 as your practice. So thanks for watching. See you again next time. Bye.